Hey guys, in this video we are going to understand about the electric current, its types, its uses and some fun facts about electric current that usually we don't know. So basically electricity is defined as that it is the energy that is due to the charged particles, which includes electrons and protons, and usually they are in motion. You see, when charges will be in motion, then it is called current, and when they are static, then it is some other field of the physics that is usually known as electrostatics, right? So basically the current is defined as the rate of flow of electric charges, and it is always divided by the unit time, means how many charges are being flown from that specific area in unit time. So its formula is I is equal to delta Q by delta T. Since the unit of coulomb is charge is coulomb and of time is second, so definitely the unit of current is amperes. And here the current is related to the power. Power unit is watt, and ampere is the unit of current, and the volts are the unit of the voltage. So if you are provided by the current and the voltage, then it's easy for you to find out the power in that circuit or whatever the situation you have. So here is an example that if V is given and I is given, then simply put it in the above formula and then you will get the power. And the component or the device that you use to measure the current from some circuit, or to exactly know that how much current is flowing from that circuit, is known as ammeter. The speed of the electricity that we usually use in our homes and whatever is given over here, and definitely it's too much. In the ECG, that is actually a medical term, what happens that a normal line in the ECG spectrum spikes when our heart beats completely normally, right? So when the current is passing, then the magnetic field is usually produced, that is visible, that makes our body visible from inside to that screen. The single spark of the electricity can cause enough voltage that is definitely too much, and it is related to the static electricity, means there is no the motion of charges, it's just a single case, mean the charges are in rest. The next thing that is very interesting over here, that when a bird is sitting on some wire, then why the electricity don't harm him? So the reason behind it is that the wires are usually insulated completely. This is the first reason, but there is also another reason, that when the bird is sitting on one wire, then the circuit is incompleted, and when his body will touch both the wires, mean both power lines, then the circuit will get completed, and in that case the bird can even die. Now we understand that how the charges can cause the electricity. So basically what happens, that the charges don't travel itself, they actually only transfer the energy from one position to the next one, and in this way the electricity is produced, as it can be seen from this diagram, that from B terminal you see that the arrows are formed towards the A terminal. So basically the electrons are on their own position, just the energy is represented by these red arrows. That is not actually the flow of electrons, that is the flow of energy through the electrons. So the basic energy is coming from this battery, that is indicated over here by the blue lines, with positive and negative terminals. So the energy is coming from negative side, and it will repel the electrons on the B terminal. Definitely the both have negative signs, so they will repel each other. So the electrons on the present on the B terminal will be forced to put their energy to the next electrons, and similarly those electrons to the next, and so on. In this way the energy is traveled from B to A terminal and then throughout the circuit. So in this way the electricity travels through some circuit. Now the very important question, that is the current a vector or a scalar? So its true answer is that the current is actually an intrinsic property of some material, mean it's not scalar and even not a vector, but usually it is considered as a scalar quantity. Scalar means that definitely it's not have some specific direction. So to understand it, you can take the example that, for example, in your homes, as you see that there are many copper wires from which the electricity is flowing. Now when you bend that wire, then definitely the current direction will also be changed according to the direction of the wire. So it means that current itself don't have some specific direction, it will gain the direction that will be given by the wire, right? So in that case the current is a scalar quantity. Now there are two types of the current, that is according to its direction, that is direct and alternating. So direct current is that flows in the single direction, like in the case of batteries, as I can show you over here. Yeah, so here you see that red arrows from battery indicates the direction of the current through this battery. So it will be definitely in one direction, right? Now the second type of the current is alternating, in which the direction of the current keeps changing itself. Now according to the types of the charges, the current can also be subdivided into further types, that are electronic current and conventional. Electronic indicates the charges will be electrons, and the conventional indicates that the charges will be protons or the positive charges. So in case of electronic current, the electrons will flow, so definitely there is a negative charge on the electrons, so this current will flow from the negative terminal to the positive, right, as mentioned above. And in the case of conventional current, it will flow from the positive to the negative terminal of the battery, right? And one thing that I will like to show you is that the current, there is a principle about current that is known as the Kirchhoff's principle of current. According to that, the current coming to one point is from various directions is equal in mean here you see that there are two currents that are 5 ampere and 5 ampere, right? Now both of them have opposite directions. Now when they are meeting at one point, then the resultant of both is given over here, right? So this is a junction at which the current is actually doubled, mean that has been in the form of sum. So that's the Kirchhoff's principle of current. Thank you very much for watching this video.